Imagine a universe no longer young, no longer teeming with light and life. Imagine a cosmos aged beyond comprehension, cold, dark, and vast beyond measure. In this infinite silence, surrounded by nothing but emptiness, there drifts a single proton. It is the very last of its kind. Once, there were countless trillions of them, the building blocks of all that ever was. But now, only one remains. It is old, unimaginably old, having survived through eons that would outlast the rise and fall of galaxies, stars, and entire civilizations. If this proton could think, if it could feel, perhaps it would be overwhelmed by memory. Perhaps it would reflect on all that has come before, the fire of the first stars, the birth of life, the fading of light, the silence that crept across the heavens. Perhaps it would feel the sorrow of being the final witness to a universe winding down. Alone in the darkness, it waits, not for salvation, but for inevitability. For even the most enduring structures in nature are not truly eternal. This is the story of that proton, a story of origin, of transformation, of cosmic cycles and endless time. It is the story of everything and of how, eventually, everything comes to an end. In the beginning, there was no light, no space, no time, nothing, and then everything. The universe burst forth not from a place, but from a moment, a single flash of existence that marked the birth of reality itself. This was the Big Bang, though it was not a bang in the traditional sense. It was not an explosion through space, it was an explosion of space. A sudden expansion from a singular state, smaller than a particle, yet containing all the energy and potential that would one day become galaxies, stars, planets, and life. A hundredth of a millionth of a billionth of a billionth of a second. After this moment of creation, the universe erupted into a frenzy of change. Time had barely begun, yet space was already inflating at an incomprehensible rate. A process known as cosmic inflation took hold, driven by forces we still do not fully understand. In the blink of a cosmic eye, the universe expanded by a factor far beyond imagining, smoothing out irregularities and setting the stage for all that would follow. The energy fueling this inflation did not disappear. It transformed, pouring itself into the fabric of the cosmos as matter and radiation. In this newborn furnace of creation, a violent and radiant soup of particles swirled in the fire. Quarks collided with antiquarks, electrons danced with photons, and neutrinos sped away like ghosts. The universe was still blisteringly hot, far too hot for anything stable to exist. But as space expanded, the searing temperature began to drop. Within a millionth of a second, the universe had cooled just enough for a critical event to unfold. The strong nuclear force, one of nature's fundamental forces, could now bind quarks together into triplets. For the first time, protons and neutrons emerged from the chaos. Even then, the cosmos was still a battlefield of transformation. Protons became neutrons. Neutrons became protons. These particles did not hold their identities for long, flipping back and forth through high-energy collisions. But the universe kept cooling, and by the time it was a single second old, it had reached 1 billion degrees Kelvin. A strange calm began to settle. The rate of change slowed. Protons remained protons. Neutrons held their form. And under the growing influence of the strong force, these particles fused into the first atomic nuclei, primarily hydrogen and helium, the simplest and most abundant elements of the cosmos. This process, called primordial nucleosynthesis, lasted for only about 10 minutes. In that short window, the elemental foundation of the universe was set. About 3/4 of all matter became hydrogen nuclei, single protons. The rest mostly formed helium, composed of 2 protons and 2 neutrons. Somewhere in that swirling inferno, our proton found its place, bound into the heart of a helium nucleus. It had no awareness of its journey, no knowledge of its future, but it was now part of the cosmic story. The fire of the Big Bang slowly faded. The universe continued to expand, and as it cooled further, the radiation from its birth lost its grip. For hundreds of thousands of years, the universe remained a glowing plasma, opaque, with light unable to travel freely. Electrons and atomic nuclei could not stay bound. Radiation constantly tore them apart. But then, at last, the cosmos cooled to just a few thousand degrees. The photons no longer had the strength to disrupt atoms, and the electrons settled into stable orbits. Light was set free, and the universe became transparent. This was the moment of recombination, the birth of the cosmic background glow that still whispers through space today. The cosmos was now a sea of neutral atoms drifting in darkness. The light of stars had not yet ignited, but gravity had begun its slow, patient work. In the vast silence, matter began to clump, pulled together by the invisible hand of attraction. Dark matter, that elusive, unseen substance, was the architect of this stage. It began to form halos, dense regions where ordinary matter would gather, and the hydrogen and helium atoms, born of the Big Bang, flowed into these gravitational wells. Among them was our tiny helium atom, cradling the proton that would one day see the end of everything. The story of the proton is a story of beginnings, of the first fractions of a second, when physics ruled with raw simplicity, of how energy became matter and how matter began to organize itself. From the unimaginable brightness of the origin to the calm neutrality of the early universe, this journey had only just begun. But already, the seeds of complexity had been sown. In the quiet, the stars were waiting to be born. The proton was not born in a singular, defined moment. It did not spring into being with the clarity of a lightning strike. Instead, it emerged from the confusion of a young universe, formed not by intention, but by circumstance. Just a millionth of a second after the beginning, the universe had already cooled enough for quarks to cling together. Held tightly by the strong nuclear force, nature's most powerful glue, 3 quarks locked themselves into a delicate, balanced dance. This was the birth of the proton. Bound by an exchange of gluons, these quarks never touch, never rest. They oscillate endlessly inside the proton's tiny shell, spinning and churning with quantum tension. The strong force, unlike gravity or electromagnetism, grows stronger with distance. The further you try to pull quarks apart, the tighter the force pulls them back together. This confinement is what makes the proton stable. It is what allows this simple particle to endure longer than stars, longer than galaxies. The proton was built to last. But even in its birth, the proton was not alone. It had a sibling, the neutron, differing only by a quark's identity. In the early chaos, protons and neutrons constantly transformed into one another through weak nuclear interactions. This cosmic identity crisis lasted only as long as the universe stayed hot and dense enough. As the seconds ticked forward and the temperature fell, these transformations slowed. Eventually, most neutrons decayed or became locked in helium nuclei, while protons, slightly more stable, persisted. Our proton found itself captured, perhaps within a helium nucleus, joined by another proton and two neutrons. In that tiny space, held together by the strong force, the particles danced a complex quantum ballet. Even here, their identities continued to flicker, protons morphing into neutrons and back again through internal interactions. Yet, as the universe aged and cooled further, these flips slowed and the identities solidified. Still, our proton was already marked by transformation. Born of a trillion interactions, it was never just a thing. It was a process, a memory of motion frozen into matter. For millions of years, the proton drifted through a universe without stars. Locked in a helium nucleus, it wandered through vast clouds of gas and darkness. But the silence would not last. Gravity was at work, slowly gathering matter into denser and denser clumps. Someday, these clouds would collapse under their own weight, and fire would return to the cosmos. But for now, the proton was patient. It had time. It had always had time. And so, the proton waited, not as an observer, not as a thinker, but as a witness nonetheless. It was the silent thread that would weave itself through atoms, through stars, through planets, and life. From the first breath of the universe, it had taken its place as one of the most enduring actors in a cosmic story that was just beginning. For hundreds of thousands of years, the universe remained cloaked in a thick, glowing fog. Though it had cooled greatly since its fiery beginning, it was still far too hot for atoms to form. Electrons and nuclei existed, but they were locked in a violent dance with radiation. Every time an electron tried to bind with a nucleus, a high-energy photon would rip it away. The universe was a seething plasma, brilliant but opaque, a place where light could not travel freely, and matter had not yet found peace. Yet, the universe was expanding, and with that expansion came cooling. Slowly, the fierce energy of the early cosmos began to settle. Around 380,000 years after the beginning, the temperature had dropped to just a few thousand Kelvin. Finally, the photons, the carriers of light, had lost enough energy. They could no longer prevent the electrons from joining the nuclei. This was the moment of recombination. Electrons curled into orbits, and the first true atoms were born. The fog lifted, and light was set free to travel across the cosmos. The universe changed forever in that moment. What had been a churning sea of particles became a calm and transparent ocean of hydrogen and helium gas. The glow from that release of light, now known as the cosmic microwave background, still surrounds us, a whisper from that ancient time. Our proton, cradled in a helium nucleus, drifted through this young and quiet universe. The fires of creation had subsided, and now came the long, slow gravitational pull toward structure. But for now, the universe had entered its first true darkness. In the vast stretches of this dark age, a new actor began to assert its influence. Dark matter, silent, invisible, and unreactive to light, began to shape the cosmos. Though it did not interact with ordinary matter through the familiar forces, it responded to gravity, and that was enough. It clumped, drawing hydrogen and helium gas into its gravitational wells. It laid down the hidden scaffolding of the universe. The galaxies had not yet formed, but their future homes were already taking shape. Our proton, locked in its helium shell, followed the current of this gravitational tide. Pulled slowly but surely toward denser regions, it wandered through the cold expanses. Though it had no mind, no purpose, it was being swept into the next phase of the cosmic story. From the simplicity of atoms would come complexity. From darkness would come light again. The age of stars was waiting to begin, and the universe, having taken its first breath, was now preparing to speak. The universe had entered a time of stillness. After the roaring birth of particles and the quiet forming of atoms, it was now a place of darkness. No stars burned, no galaxies turned. The only light that remained was a faint cosmic afterglow, stretching and fading as space continued to expand. But though the universe seemed quiet, something profound was beginning to take shape. Gravity was at work, slow, patient, inevitable. In the darkness, matter began to gather. Dark matter, invisible and silent, was the unseen architect of this transformation. It clustered into dense regions, drawing ordinary matter along with it. Hydrogen and helium gas, born from the Big Bang, flowed into these dark matter halos. Over millions of years, the clumps grew larger. The quiet gas clouds began to swirl and collide, compressing into tighter knots. The gravitational seeds of galaxies were being sown, scattered across the expanding fabric of the cosmos. Some of these clouds grew so massive that their cores began to collapse under their own weight. As the gas compressed, its temperature soared. At the center of these clouds, the pressure became immense. Electrons were stripped from atoms, and the swirling plasma glowed in invisible light. Deep within, temperatures reached millions of degrees Kelvin, and in those hearts of heat and pressure, something remarkable happened. Protons began to fuse. The universe had lit its first stars. These first stars were giants, far more massive than most stars born today. They formed quickly, burned furiously, and lived short, brilliant lives. In their cores, hydrogen fused into helium, releasing vast amounts of energy that pushed back against gravity and caused the stars to shine. Light burst back into the universe, ending the long darkness. For the first time since the Big Bang, the night sky began to glow, not with the dim afterglow of ancient radiation, but with the fire of newborn stars. Our proton, still nestled in its helium nucleus, may have found itself swept into one of these stellar furnaces. If not in the core, then in the atmosphere, caught in swirling convection currents. It was now a part of something vast and alive, a star that pulsed with nuclear fire. And though it had no memory, no awareness of its journey, the proton had entered the stage of cosmic transformation. The universe, once formless and cold, had begun its long journey toward complexity, with stars as its burning beacons. The first stars burned brightly, but briefly. Their great masses meant their lives were fast and furious, ending in colossal explosions. As their hydrogen was exhausted and fusion moved on to heavier elements, their cores eventually collapsed. And then, in a moment of unimaginable violence, they died. Supernovae, celestial detonations so bright they could outshine entire galaxies, ripped through space, scattering the elements they had forged. In these final moments, the surrounding gas, dust, and everything once held tightly by gravity was flung into the void. Our proton, perhaps still within a helium nucleus, was hurled outward during one of these cataclysms. It traveled through interstellar space, through the ashes of its former star. For a time, it wandered, drifting through cold gas clouds, untouched by the forces that once shaped it. But the universe was still young, still forging stars from the wreckage of those that came before. Eventually, the cloud that held our proton began to collapse again. Drawn together by gravity and cooled by radiation, it was pulled into a new knot of gas. Another star was about to be born. This second star was different. Smaller, more stable, it burned slower and lived longer. Within its glowing core, the cycle began again. Hydrogen fused into helium, and our proton, if now part of a hydrogen atom, might have joined that process, sacrificing itself to create new elements. Or perhaps it remained in the outer layers, swirling through convective currents, rising and falling through the layers of the star. Either way, it was participating once more in the cosmic rhythm: birth, transformation, and death. As billions of years passed, the star aged. Its hydrogen thinned, its structure changed, and when the time came, its atmosphere pulsed and heaved, releasing layers of gas into the cosmos. Our proton was carried outward once more, this time not in a blaze of destruction, but in a gentle shedding. The star became a white dwarf, a cooling ember of its former brilliance. But the gas it expelled, rich in carbon and other heavy elements, drifted outward into the interstellar medium, ready to seed new generations of stars and planets. Again and again, this cycle would repeat. Our proton could become part of a new atom, fall into another star, be forged into a heavier nucleus, or settle into the crust of a forming world. With each passage, it was changed, yet always remained itself. The proton, born in the fire of the Big Bang, would carry on through the lifetimes of stars, the formation of planets, and the rise and fall of celestial structures. It was not just a building block of matter, it was a traveler across time. The galaxy had grown older. The stars had cycled through their births and deaths. The gas that remained was no longer pristine. It carried the ashes of countless stellar ancestors, rich with heavier elements. In one quiet corner of the Milky Way, a cloud of this enriched material began to collapse. Gravity pulled it inward. It spun and flattened into a disk, glowing with heat, as a new star took form at its center. That star would one day be called the Sun. Around it, the leftover dust and gas began to stick together, grain by grain, forming the seeds of future worlds. Amid this cosmic construction, a small rocky planet emerged, third from the Sun, surrounded by a young atmosphere and bombarded by comets and asteroids. Earth was born in fire. Its surface roiled with volcanic storms, its skies choked with vapor, and its crust was thin and unstable. But as the planet cooled, water gathered in basins, rain fell, oceans formed. And somewhere within this watery world, the conditions became just right for something extraordinary. Chemistry began to take a new direction. Molecules linked, folded, and formed the first whispers of life. Our proton, having traveled across generations of stars, now found itself in the crust of this young Earth. Perhaps it was part of a carbon atom, weathered into the sea. Perhaps it joined with oxygen and hydrogen, becoming a molecule of sugar or a strand of protein. It did not matter what form it took. What mattered was the role it played. On a planet bathed in sunlight and swirled by tides, life was stirring. And our proton was no longer just part of matter. It had become part of something living. For billions of years, life remained simple. Single cells ruled the oceans, feeding, dividing, adapting. Some formed colonies. Others learned to capture sunlight, transforming light into energy and breathing oxygen into the atmosphere. Over time, the Earth changed. Its surface cooled and stabilized. Its continents drifted and collided. And eventually, more complex life emerged. Plants reached upward. Creatures crawled from the sea. Insects took flight. Forests grew. And our proton, carried through food and breath, might have moved from leaf to insect to fish to mammal, becoming part of the ever-changing story of biology. It is strange to think that something so small, so ancient, could be part of something as fragile and fleeting as life. But that is the magic of the cosmos. The particles that once floated in the darkness between stars can one day think, feel, and wonder. Our proton, born in the fire of creation, now pulsed in a living cell, perhaps part of a tree, or a fish, or even a human being looking up at the stars. The journey from stardust to life was long and winding, but it was far from over. For most of Earth's history, life remained microscopic. The planet's surface was home to bacteria and single-celled algae, quietly shaping the atmosphere and oceans with every breath and reaction. But evolution never stands still. Over countless generations, life experimented. It built new structures, adapted to new environments, and eventually, complexity emerged. Multicellular organisms evolved. Plants colonized the land. Animals followed. The biosphere bloomed into a tapestry of form and color. And our proton, still anonymous and eternal, flowed silently through these rising waves of life. Perhaps it moved through the sap of a towering tree, or passed from the gills of a fish to the bloodstream of a reptile. Over the ages, it took part in photosynthesis, in digestion, in respiration. It danced through cycles of death and rebirth. And then, much later, it found itself somewhere new, woven into a strand of DNA, folded inside a cell, nestled in the body of a creature unlike any that had come before. That creature walked upright, gazed at the horizon, and began to wonder. It was human. And for the first time, the proton became part of a being that could question its own existence. Humanity did not arrive with fanfare. It crept onto the stage of Earth's history with quiet steps and stone tools. But within its fragile body was something extraordinary: the capacity for thought, for language, for memory. Humans painted caves, built fires, and told stories about the sky. They looked up at the stars and asked where they came from. And in doing so, they unknowingly asked about the proton itself, its origins, its nature, its place in the cosmos. For the first time, the universe had created something that could reflect upon itself. The proton might have been part of a human breath, or a heartbeat, or a tear. It might have been forged into a tool, or embedded in a diamond passed from one generation to the next. Perhaps it lay buried in the earth, only to be uncovered by hands driven by curiosity. Humanity built cities, wrote books, sent machines to the moon, and eventually peered so deeply into matter that it discovered the proton itself. After billions of years, one of the building blocks of the universe was finally recognized by those who were made from it. But nothing lasts forever. Civilizations rose and fell. The wonders of one age became the ruins of another. And through it all, the proton endured. It passed through fire, water, bone, and metal, sometimes hidden, sometimes revealed. It had been part of life, part of death, and part of dreams. And as the human chapter faded into memory, the proton remained, unchanged in essence, patient in its passage through time. Its journey with humanity was only a moment, but it was a moment filled with meaning. Time passed, stars aged, civilizations flourished and vanished, and far beyond the concerns of any single world, the great structures of the cosmos continued their slow, celestial dance. The Milky Way, home to our proton and all that ever lived on Earth, was not alone in the darkness. Across the void, another island of stars approached, Andromeda. A galaxy not so different from our own, spiral in shape, ancient in age, massive in form. For billions of years, the two had been moving toward one another, drawn together by the quiet but relentless pull of gravity. When the moment finally arrived, it was not sudden. The collision between galaxies unfolds over billions of years, a vast ballet of stars and gas stretching across time. From a distance, it would be a thing of beauty, spirals twisting, arms merging, halos overlapping. But within, it was chaos. Immense clouds of gas collided, igniting waves of star formation. The night sky lit up with newborn stars and dying giants, exploding in waves of light. The heavens, once familiar, were transformed into a storm of creation and destruction. Our proton, perhaps buried in the crust of a ruined world, may have missed the spectacle. Or perhaps it was cast into the currents of stellar debris, swept into the gas streams flowing through the merging galaxies. It may have journeyed deep into the gravitational tides, or fallen toward the central maelstrom, where two supermassive black holes spiraled toward one another. The proton did not know. It could not see. But it was there, once again moving through the ever-shifting architecture of the universe. The Milky Way and Andromeda would not remain separate for long. Over time, their cores would merge. Their stars would mix and settle into a new shape, an elliptical galaxy, broader and older than either had been alone. The night skies from within would look different now. The gentle spiral arms of the past would be gone, replaced by a dense sea of starlight. For any future observers, the memory of the old galaxies would fade, replaced by a new and merged identity, Milkdromeda. This grand event marked a new chapter in the story of the cosmos. It was a reminder that even the mightiest of structures are not fixed forever. Galaxies grow, evolve, and perish, just as stars and worlds do. And through it all, the proton remained, unshaken, ancient, enduring. It had been part of a star, part of a planet, part of a living thing. Now it was part of a galaxy reborn, still journeying, still waiting for whatever might come next. The sun has always been our star, warm, steady, and ancient, beyond human comprehension. But even stars have lifetimes. The same nuclear fire that brought life to Earth has a limit. Deep within its core, hydrogen is slowly but steadily consumed, transformed into helium through fusion. For billions of years, this balance between gravity and radiation held. But time cannot be paused, and the day will come when the core's hydrogen runs dry. When that moment arrives, the sun will change. Its core will contract, growing hotter and denser, while the outer layers expand outward into space. The star will swell into a red giant, hundreds of times its original size. Mercury, the innermost planet, will be engulfed. Venus will follow. And Earth, our home, rich with memory and history, will face its end. The oceans will boil. The atmosphere will be stripped away. Mountains will melt. The surface will become a scorched, broken relic of what once was. Our proton, perhaps embedded in the very rock of Earth, will feel the pull. It might be part of a diamond, or a speck of dust, or a cell long since turned to ash. As the atmosphere of the sun reaches out, Earth's orbit will decay. Dragged inward by tidal forces and radiation, the planet will spiral toward its demise. The crust will fragment, the core will shatter, and in a final act of cosmic violence, Earth will be swallowed by the star that once gave it life. But even this destruction is not the end. The sun, now bloated and unstable, will cast off its outer layers in a final breath. What remains will be a white dwarf, a dense, hot cinder no larger than Earth itself, glowing with the last heat of its past life. Around it, a shell of gas and dust will drift into space, a planetary nebula fading into darkness. Our proton, flung from the remains of Earth, will travel once more, carried into the interstellar medium, waiting for a new home, a new purpose. The death of the sun marks the end of a chapter, not just for Earth, but for the entire solar system. Moons, planets, asteroids, all will be altered, scattered, or consumed. But the proton continues. It has survived stars and supernovae, life and extinction. It now leaves behind the world that once gave it meaning, drifting through the remnants of a solar graveyard. Alone again, and yet still part of the universe's unfolding story. The universe once shimmered with the brilliance of countless stars. They were born in cosmic firestorms, burned with intensity, and died in beauty and violence. But that age is ending. As time stretches onward, star formation slows. The great reservoirs of gas that once birthed new suns have been spent, locked away in dead stars, in black holes, or scattered so thinly that gravity cannot gather them again. The stellar nursery is closing, and the lights are beginning to go out. The last generation of stars belongs to the small and the dim. Red dwarfs, the most common type of star in the universe, burn their fuel slowly and steadily. Unlike their massive cousins, they do not end in explosion. Instead, they simply fade. These stars can live for trillions of years, glowing faintly with deep red light. But even they are not eternal. As their fuel dwindles, they cool and darken, slipping quietly into the cosmic night, becoming black dwarfs, cold, dark remnants adrift in silence. Our proton may now find itself locked inside one of these quiet stars, carried through slow convective flows within its core. There is no drama, no sudden transformation, just the slow erosion of light and warmth. Over trillions of years, the last embers of nuclear fusion fade. There is no longer enough pressure or heat to continue the star's glow. The universe, once ablaze with radiance, becomes a colder and quieter place. The great stellar chorus thins until it becomes a whisper. As each red dwarf fades, the galaxy grows darker. From a distance, the Milky Way, once a spiral of fire, will appear as a dim shadow. Without new stars to replace the old, each light that dies is not reborn. The rhythm of stellar life that shaped the cosmos for billions of years comes to a halt. And yet, our proton continues. It remains within a darkened shell of matter, drifting through the remnants of what once was. It has survived the death of stars before. It survives still. This is the twilight of the universe. The age of starlight is drawing to a close. There are no new stars waiting to be born, no great explosions to dazzle the skies, just the slow extinguishing of fire, one star at a time. And as the last red dwarf goes dark, the cosmos takes on a new stillness. But even here, in the fading hush, the proton endures. Quiet, undisturbed, eternal, for now. The last stars have gone out, their warmth, their light, their energy, all spent. No more suns will rise, no more starlight will burn through the vastness. The universe, once a tapestry woven with luminous threads, is now draped in perfect darkness. It is not a night that will pass, but a shadow that will stretch forever. The galaxies are gone, scattered or devoured. The skies are no longer filled with points of light, only with the silence of things that no longer shine. Drifting through this black and endless void are the remnants of creation. Cold white dwarfs, neutron stars, and black holes. Islands of matter that no longer live, only exist. Occasionally, these dead stars may collide, sending brief ripples through space-time, but the light they create fades as quickly as it appears. The universe has entered a time where nothing new is born. It is not chaos, it is quiet. The quiet of entropy, the quiet of finality. Our proton, still intact, still unchanged since the earliest moment of the cosmos, now floats through this stillness. It is a relic of a brighter age, a survivor of stars, planets, and life itself. No longer pulled by gravity into new stars, no longer cycled through galaxies or bodies, it wanders alone. There are no voices, no colors, no warmth. Only the cold drift of time, moving forward without destination. If this proton could think, it might wonder, is this the end, or just another beginning waiting to happen? But even matter, so seemingly solid and eternal, is not immune to time. The proton, stable through all previous epochs, now faces a new fate. For the laws of physics allow for a possibility, however rare, that even protons can decay. And in a universe where time is infinite, even the rare becomes inevitable. One by one, across the endless eons, protons begin to break apart. A single flash, a release of energy, and then nothing. The darkness deepens. The silence grows thicker. With the disintegration of the last protons, the building blocks of all matter vanish. No atoms remain, no molecules, no dust, no structure. What is left is an ocean of radiation, of low-energy photons and particles, stretched thin by the continuing expansion of space. The universe, once vibrant and full, is now nearly empty. It has reached a kind of stillness beyond imagination. But as long as space and time persist, perhaps the story is not quite over. For so long, matter has felt permanent. Stones endure, bones fossilize, ancient monuments stand for millennia. Even stars and planets, though born and destroyed, are made from protons and neutrons that seem unshakably stable. But time is patient, and in the long view of the cosmos, even the strongest things begin to falter. After the death of stars and the fading of galaxies, only a scattered fog of fundamental particles remains. But even these, the very building blocks of everything, may not be immune to the deep erosion of time. The proton, once the sturdy core of atoms, may eventually fall. Though it lives longer than stars, longer than black holes, and longer than memory, the theories of physics allow for its decay. Quantum uncertainty leaves open the faintest chance that a proton may suddenly cease to be, transformed into lighter particles, vanishing with a whisper of energy. It is a process so rare, so slow, that it has never been witnessed. But in a universe measured not in billions, but in trillions upon trillions of years, the rare becomes inevitable. One by one, across unfathomable timescales, protons begin to disappear. With each vanishing, a fragment of matter is lost forever. Structures fall apart at the most fundamental level. Molecules lose cohesion. Crystals unravel. Even the most inert of elements disintegrate into radiation and subatomic mist. It is not a fiery end, nor a violent collapse. It is a quiet dissolving, the slow unmaking of reality as we have known it. The universe becomes not just cold and dark, but disassembled, atom by atom, until none remain. Our proton, which had traveled through stars, through life, through planets and time, now faces this fate. After trillions of years adrift in emptiness, it too reaches its final moment. It does not cry out, it does not resist, it simply ceases. In an instant too small to measure, it decays, its energy scattered into the thin, expanding cosmos. One more light extinguished in a universe where even light has grown too faint to matter. Nothing remains of its long and storied journey, but the memory we give it now. And so, matter ends, not in explosion, but in quiet release. The universe becomes a sea of nothingness, no atoms, no bonds, no form. Only faint radiation remains, stretched across an ever-growing void. With the death of protons, the last true scaffolding of existence is gone. Time still moves forward, but now there is nothing left to change. It is a universe emptied not by force, but by inevitability. A silence deeper than death. A darkness older than stars. And perhaps, just perhaps, not the end, but a pause before something else. Across the vastness of time, everything changes. Stars flare and die. Galaxies collide and dissolve. Civilizations rise, dream, and vanish. Yet throughout this cosmic unfolding, one thing has remained: the humble proton. It has been the foundation of matter, the bedrock of atoms, the survivor of fire and silence. Through every transformation, through every cosmic age, it endured. But not even the proton is truly eternal. In the quiet, in the cold, after all else has faded, comes its final moment. The decay of a proton is not a grand event. There is no explosion, no spectacle. It is a quiet flicker, a vanishing so subtle that it leaves no trace. Theories suggest that after an unimaginable amount of time, measured not in trillions, but in powers beyond comprehension, a proton may spontaneously decay. It transforms into lighter particles, releasing a whisper of energy. A journey that began in the first second of the universe ends not with a bang, but with a barely audible farewell. Imagine this one last proton, drifting in the darkness. It has seen the birth of stars, the shaping of worlds, the spark of life. It has wandered through stellar cores and planetary crusts, through oceans and organisms. It has been part of stories it could never know. And now, it is alone, utterly and completely. No galaxy shines, no warmth remains, no other protons to share its fate. Just this one, waiting in the absolute quiet of an aging cosmos. And then, after a time so long that meaning breaks down, it happens. The proton decays. In a single, silent instant, it ceases to be. A flash of pure energy dissolves into the emptiness. It is not violent. It is not tragic. It is natural. It is the final transformation in a journey that has lasted longer than stars, longer than time as we understand it. The universe has taken back one of its oldest travelers. One more thread in the fabric of matter has been gently unraveled. With the fall of the final proton, a profound stillness settles over all things. There is no more structure, no more substance. The matter that built the stars, that carried the light, that held the memories of life, is gone. Yet in that final release, in that last spark of decay, the story of the universe continues to echo. A whisper carried across space-time. The end of the proton is not just the end of a particle. It is the quiet closing of a chapter that began at the very beginning. And in its absence, the cosmos is left to rest, or to begin again. Even after the last stars have gone dark, after every atom has unraveled into radiation, one type of object still remains: black holes. They are the most extreme structures in the universe, the collapsed hearts of ancient stars, and the colossal anchors at the centers of dead galaxies. Black holes are not made of matter in any familiar sense. They are pure gravity, wrapped in a one-way veil, the event horizon. Beyond this boundary, nothing escapes. Not light, not time, not even memory. For eons beyond imagining, black holes will dominate the darkness. They do not shine, they do not pulse, but their influence is vast. They drift through the black void, swallowing the occasional remnant, a rogue particle, a fragment of radiation, or a dead star unlucky enough to wander too close. At the core of each black hole lies a singularity, a point where the known laws of physics fall apart. They are the universe's last engines of entropy, its final wells of gravitational depth. Yet, black holes, too, are not eternal. In the quantum world, even the most immovable objects can unravel. Stephen Hawking revealed that black holes radiate, not through light, but through a subtle quantum process near the event horizon. Virtual particles pop into existence. One escapes, the other falls inward. Over time, this Hawking radiation slowly drains the black hole of energy. Imperceptible at first, it grows stronger as the black hole shrinks, a process that takes longer than the lifetime of stars, galaxies, or even protons. The smaller the black hole becomes, the faster it fades. In the end, when only the tiniest fragment remains, the radiation surges. In a final flash, brief, bright, and silent, the black hole evaporates completely. No trace remains. This moment, in a universe that has known only darkness for uncountable eons, is the last burst of light. Not from a star, not from fusion, but from the purest transformation of mass into energy. The universe exhales its final breath of brilliance. And then, silence. With the death of the last black hole, there are no more engines left to churn reality. No more collapses, no more explosions, no more light. The universe has grown old. It has emptied itself of structure, of energy, of change. But this is not an end filled with fear. It is an end filled with wonder. That something so vast, so full, so alive, could give way so gently. The black holes, once feared as cosmic destroyers, have become the final storytellers. Their light, fleeting though it was, marks the close of all things. With the final flash of the last black hole, the universe enters its quietest chapter. There are no more stars, no more light, no more matter as we once knew it. All that remains is an ever-expanding fog of low-energy photons drifting endlessly through an ocean of space. There are no structures left to form, no events left to unfold. This is not the dramatic collapse once imagined by ancient thinkers. It is the slow fading of a grand symphony, a final, prolonged note that stretches across eternity. This state is known as heat death. It does not mean the universe grows hot. It means the universe has reached thermal equilibrium. Energy is spread so evenly across space that no work can be done. There are no gradients, no movement, no differences to fuel change. Entropy, the measure of disorder, has reached its maximum. Every transformation that could occur has occurred. The cosmos is now static, not because it is frozen, but because there is nothing left to rearrange. In this final state, even time begins to lose meaning. For what is time without change? Without contrast or causality, there is no way to mark one moment from the next. Clocks do not tick. Events do not unfold. Time, once so fundamental to our experience, becomes an empty dimension, present in theory, but hollow in substance. The flow of time slows not in speed, but in relevance. It continues only as a silent backdrop to nothing at all. Our proton, long vanished into decay, is no longer here to drift. The stars that once flared and the galaxies that once spun are now forgotten echoes. Even radiation itself grows colder, weaker, redshifted into wavelengths too vast to interact with anything. The universe is not dying in a blaze, it is fading in a hush. The once dynamic cosmos has become a vast, quiet plain, a sea of sameness stretched thin by the eternal expansion of space. And yet, perhaps this is not an end but a transformation. Perhaps heat death is not a final silence, but the pause between breaths. A universe at rest, holding within it the potential for something new, something unexpected. But until that moment, if it ever comes, the cosmos sleeps. There is no more light to shine, no more stories to tell. And in this quiet, stretched across a void without clocks or boundaries, the universe has finally grown still. This is the death of time, not with finality, but with peace. Physicists believe dark energy is a field of energy that permeates all of space. Unlike matter or radiation, it does not dilute as the universe expands. Its density remains constant, and because of that, it dominates more and more as everything else thins out. But if dark energy follows the rules of quantum mechanics, then it may not be forever. Even something that appears changeless can, in time, shift. It could decay, slowly, suddenly, all at once, into something new. This idea is more than speculation. It is rooted in the strange behavior of quantum fields, fields that can tunnel from one state to another. If dark energy is not in its lowest possible energy state, then someday, whether tomorrow or in 10 to the power of 10 to the power of 50 years, it could fall into a lower state. That transition would release a tremendous amount of energy, a ripple through space, a rewriting of the laws of physics, a new explosion, not of matter, but of possibility. If that moment ever comes, it would be like a new Big Bang, erupting within the stillness of heat death. The energy released could ignite a new era of creation, spawning particles, forces, and maybe even space-time itself. Entirely new universes might bud from this event, each with its own structure, its own physics, its own fate. Some may be lifeless, others may be rich with stars and light. Perhaps, somewhere in that cosmic renewal, new protons will form, and the story will begin again. In the vast darkness, where even time has lost its meaning, this is the whisper of a final hope. The idea that the cosmos is not a closed book, but a cycle, a breath. That from silence, music might rise again. The decay of dark energy may be the final transformation, the last act of the current universe, and the first chapter of the next. For now, we wait in the long pause. But the cosmos has always found a way to surprise us, and perhaps it is not done telling its story. From a single flicker of creation to the final breath of space and time, we have followed the journey of a single proton, a particle so small, so unassuming, yet so persistent. It was there in the first second of existence, born in the fires of the Big Bang. It passed through the hearts of stars, the crust of worlds, the pulse of living cells. It traveled across billions of years, carried by gravity and chance, never aging, never tiring. And in its journey, it mirrored the universe itself, expanding, transforming, enduring. This was not just a story of a proton. It was a story of everything, of how from chaos came structure, of how from silence came stars, of how matter gathered, collapsed, ignited, and scattered. And from that scattering came life, a fragile, curious flicker of awareness that looked up and asked questions, that measured the heavens and wondered where it fit in the story, that told myths, built equations, and whispered to the night, hoping the cosmos would whisper back. So, as we close this journey, remember, everything ends, but nothing is truly lost. The proton, like the universe, was never still. It became light. It became memory. It became us. And in us, in our questions, in our awe, in our stories, it continues. The universe may fall silent once more, but as long as there are minds to wonder, voices to speak, and stories to tell, the light has not truly gone out. It only waits to shine again. If you enjoyed this video, please give it a like and subscribe to our channel. Let us know your thoughts in the comments. We'd love to hear from you. Thanks for watching, and we'll see you in the next one.